In the last two videos, I showed how to build a SilverHat booster. Today, I am going to show you how to make it look nice using the 3D printed IoTT Cube frames, which, by the way, can also be used to beautify a DCC EX command station. Hello everyone and welcome to the IoTT channel. I am Hans Tanner. A special welcome to all new subscribers and welcome back to everyone else. I am happy you made it here and thank you for your support of my channel. Just as a quick memory refresher, the SilverHat booster is based on Arduino and can stack up to 6 PowerShields with up to 8.5 amps output current each. Each channel supports individual overload and short circuit protection, and up to 4 of the PowerShields can support auto-reversing mode. In the Plus version, it can receive commands either from the DCC input or from LocoNet. You can send commands to turn each channel on or off, to reset it after a short circuit, or to set the polarity of the auto-reversing output. And if connected to LocoNet, it also can send a notification message in case a short circuit or overload condition occurs. The work status and current consumption of each track output can conveniently be displayed using the Monitor tab so that you always know what's happening on your layout. Building the SilverHat is quite simple as demonstrated in the last two videos. Basically just stacking up some Arduino shields. But of course a stack of bare PCBs is not really what you want to have on the layout. They do not really look that nice and generally it is also a good idea to protect electronics boards from whatever can happen. That's the purpose of the IoTT Cube frames introduced in video number 108. The idea is to provide a modular system of enclosure frames that can be 3D printed and assembled to fit the configuration of the Arduino board stack of your SilverHat booster or DCC EX command station. The frames are published on the Tinkercad webpage and available for download. You can clone them and make adjustments as you like. So let's have a look at the library and I will show you how to download, print and use the frames to create an enclosure for your command station or booster. To get started, open the Tinkercad webpage in your browser. To download the IoTT Cube frames, you need to be logged into the page, so log in with your account information. In case you do not have an account, you can create one or use your Google, Microsoft, Apple or Facebook account. Make note of how you logged in so that you do not have to start from scratch again if you later want to download updates or additional frames. Once logged in, click Collections and search for IoTT. This should produce a page that shows all IoTT designs I have made publicly available. To download a particular frame, click Copy and Tinker to clone it into your own account. Do not download it directly as each library consists of several individual part designs that should be downloaded and printed individually based on your requirements. The model is cloned and will open in the Tinkercad editor as shown here using the example of the Arduino Cube base. Another reason why I provide the entire Tinkercad model and not just STL files is that you can make changes as needed. If you want to make, for example, another opening in a sidewall of a frame, you can simply add it in the Tinkercad editor and then create a new STL file from it. Or you can change the frame models in a way that they fit with other structures on your layout or whatsoever. Your imagination is the limit. Let's have a look what individual part models are inside the IoTT Cube base library. Note that all libraries are built the same way with the same basic elements, so What I explain for the Cube base is applicable for all other libraries as well. On the left side there are two different versions of the base plate, one with and the other without mounting brackets. Besides that, they are identical and have the guide pins and openings to place the Arduino board. Select one of the models depending on whether you want to screw your booster or command station to a board or not. Then there are two versions of the top frame which is mounted after placing the Arduino board on the base plate. One version is for Arduino boards with the traditional USB Type-B connector. The other is for more modern boards with USB Type-C connector. Other than that, they are identical. So to make your own base frame, you download one of the base plates and one of the top frames, depending on your requirements. To download, you click the frame you want, then click the Export button. A new dialog opens. Make sure the option "The selected shape" is checked and select the data format you need for your printer. In my case, I use STL files, and that is probably the case for most filament printers. The browser asks you then what to do with the file. Select Save As and define a file name and location. There are two more parts included in the model which are used if you want to make a two-color printout, which is possible if your printer has the capability of printing two colors at the same time. Preparing the model for a second color is a two-step process. First, you need to create a cavity in the model in those locations you want to have a different color. Then you need to download separate STL files for each color, one for the main body of the frame minus the cavity for the second color, and one STL file for just the second color. So let's say you want a separate color marking around the base frame. To create the cavity, you align the base frame model with the color frame that is already defined as cavity and click the group button to join the two models to create a base frame with cavity for the second color. Then you download the STL files for the frame with cavity and the one for the color frame. After downloading the STL files, you start the slicer program for your 3D printer to create the print file. Once it comes up, open and place the downloaded STL file on the print plate. Usually the models can be placed the same way they are oriented in the library, particularly when it comes to what is up and what is down. Frames with large horizontal areas, so the base plate and the top cover, are typically placed on the build plate so that the flat surface is facing down to the build plate of the printer. This ensures that the visible horizontal surface has quite good printing quality. The typical vertical frames for Motorshield, etc. are normally printed in the same orientation as they are mounted on the stack. I have added some supports below overhanging areas to facilitate the process. To print a single color part, simply place the STL model on the build plate of the printer. If you want to print using two colors, load both STL files on the build plate and align them. Select one filament for the main body and a different color filament for the color frame. Then use the slicer function to create the print file and download it to the printer if the printer is connected to your computer. Otherwise, store it on a memory card and transfer it manually to the printer. Now you can prepare the printer and print the enclosure part. I normally use regular PLA for my prints. I find it easy to work with as the material is relatively soft. When I print the parts on my printer, they tend to stack really nice with a little click when stacked up. Also, it is very easy to remove any excess PLA material with a utility knife if needed, or to make other modifications after printing the part. For some frames I have used transparent filament, for example to make the enclosure of my red DCC EX command station shown here. I like the see-through effect, so you can see the Arduino LEDs shining through the material, which looks quite good. The disadvantage of transparent filament is that the material is more crystalline and harder than regular PLA, so it is harder to work on the printed models. Sandpaper works, but using a utility knife is more difficult, at least for me. After printing, you can cut away any support structures and clean the interface area to the next lower frame so that they can easily be stacked on top of each other. I usually use a utility knife for this. I also tried using a milling machine to clean the connection lip between the frames, but with little success, so I do not really recommend doing that. After printing all enclosure parts, it is easy to assemble the command station or booster from bottom to top. You will find that the enclosure frames make it easier to insert the individual boards as they provide a certain guidance. In addition, they provide support to the PCBs and help to keep them level in reference to each other, which makes the pin header connection between the boards more stable and reliable. To firmly close the finished stack, there are two methods available. More engineering-minded folks can use two-threaded rods in each corner and drive them into the holes in the top cover. You then cut them to length at the bottom and use a washer and M2 hex nut to secure the entire stack. To me, that is too complicated, and I prefer the wire method. I use a piece of copper or florist's wire. Each top cover design has openings on both sides to insert a wire and loop it back to the bottom. The base plate also has openings on both sides to stick the wire through. I then use needle nose pliers to twist the ends together and cut them to length with a side cutter, and the stack is secured good enough. And if needed, it is very easy to open it up, add or remove boards and enclosure frames, insert a new wire and close it again. Inside the stack, the wires run on each side of the PCBs, where there is plenty of space and no risk that the wires would touch any conducting parts. So that's how the IoTT Cube enclosure frames work. Now let me give you an overview about what enclosure frames you need to build either a SilverHat booster or a DCC EX command station. At the base in both cases is the Arduino board, either an Arduino Uno or Mega. To build the DCC EX command station, it is recommended to use an Arduino Mega, as it has more power and there are some software functions that only work on the Mega. For the SilverHat you can use the Mega, but performance-wise it is the same as the cheaper Uno. If you use the Uno, you can print the IoTT Cube base either for the USB Type-B or Type-C connector. Of course, a board with USB-C also fits the enclosure for the Type-B connector. The only downside is that the connector opening is too large. For the Mega, you can use the Mega base. Like the Uno base, the set includes two versions, one with, the other without mounting brackets. The top frame is designed for the Mega layout, and in addition, the library has two versions of the side cover, one with, the other without openings for accessing the Arduino pin headers on the Mega. The second board on the command station stack and the SilverHat booster is typically the Motorshield or PowerShield. There are three enclosure versions available. The Motorshield frame, if you are using a standard Arduino Motorshield board with two output channels and about 2 amps drag current. You can buy several versions of this shield type, but as far as I know, the board layout is identical for all of them, so the frame should fit all standard board versions. The second option is the DCC X8874 Motorshield. It is similar to the standard Motorshield enclosure, but the openings fit the various connectors of the X8874 Motorshield. And finally, the enclosure for the IoTT PowerShield board. This library includes two different frames, one for the version with the onboard power chips and one with an opening for a flat ribbon cable to connect an external IBT2 module. For a simple command station you can use the blind cover to put a lid over the Motorshield board. The blind cover library has two versions as well, one with, the other without openings to access the Arduino pin headers. It also has two different versions for a DCC EX logo insert that you can use to create a DCC EX logo in a second color right on top of the command station. And there is even an additional cutout you can use if you want to create your own logo to be printed on top of the box. If you are using a Wi-Fi shield on your DCC EX command station, you can use the spacer frame as enclosure around the shield, and on top you place the Wi-Fi shield cover. Also, this cover has the option to add the DCC EX logo in a second color if you like. There are additional enclosure frames for the DCC aux shield and the RedHat shield if you want to put an IoTT stick on your DCC EX system to make it a LocoNet command station. For the SilverHat booster, I have created a special library that has all the frames you need for the SilverHat, including the Tinkercad shield. The library includes two versions of the enclosure, one for the SilverHat Basic and one for the SilverHat Plus version. The basic version has a special PowerShield enclosure which puts a partial top cover over the topmost PowerShield in the stack. Mount this top cover right on top of the PowerShield. Then add the Tinkercad shield. The Tinkercad enclosure is then screwed on the top cover using 2x10mm screws. For the Plus version, you use the other cover, which is a modified RedHat top cover and has an opening for the IoTT stick. Mount this cover on top of the aux shield and install the growth port cable using the opening in the cover. Then place the Tinkercad shield on top of it and screw on the Tinkercad enclosure. Note that the Tinkercad enclosure for the Plus version is slightly different from the one for the basic version, so make sure you are using the correct one. And that's it for this video. I hope this information was useful or at least interesting for you, and it gave you some ideas how you can use the IoTT Cube frame libraries to beautify your DCC EX command station or SilverHat booster. If you have a 3D printer available, it should be easy for you to try it for yourself. Otherwise, you may want to use a commercial printing service. I have never done so, but plan to try one of the providers in the near future and show the results in another video. Make sure you subscribe to the IoTT channel and activate the notifications function so that you do not miss this upcoming video. And if you like what I showed in this video, please click the like button to let me know or leave me a comment in the comment section below. I always love to hear from my viewers and learn about their own ideas, so please use it. Thanks for watching and see you in the next video.